Okay. Okay, this is the problem we have to solve. So let f be the function defined above, this one. And for what value of b is f continuous at x equals 2? Okay, so I'm going to see for which of these, for what value of b this is continuous in 2. Okay, here is the point. Because this is a multiple choice, I'm going to put a 2 right here, and I'm going to put a 2 right here, and then I'm going to make them equal, and I'm going to solve. It's not valid to put a 2 here because, well, right here, only with the limit. But because nobody's watching, you can easily put a 2 and check if this is the same value here. So, what do you have? Well, 2 squared minus 7 times 2 plus 10 over b, 2 minus 2 equals b. Here is a problem. What is the problem?
0.
And what you have at the top? 0. You see? 4 plus 10, 14 minus 14, 0. So this is a 0 over 0. Okay. So I have to do something. X squared minus 7x plus 10 over bx minus 2. I have to change this expression. So what is the good idea? If this is 0, this has to be here. So I don't have to think too much. What is the factor missing?
X minus 5.
X minus 5, that's correct. So this cancels this, and then you have x minus 5 over b. So this expression is equivalent to this one, you see? Algebraically, this is equivalent. But this expression in 2 is fine. So we're going to put this f of 2 is going to be, okay, I'm going to put 2 minus 5 over b, and then b, correct? So what is going to be this one? Negative 3 over b, and this is going to be b, correct? Okay, now what I have to do, make them equal. Negative 3 over b equals b. Okay, now, do you have a solution for that problem?
No.
Why?
Negative 3 equals b squared. No?
If you multiply times b,
You can take the square root.
Yeah.
and then you don't have square root, that's correct. So no value b makes f what? Continuous. Correct? So there is no value b making this continuous. That's it.
El examen va a ser free response.
¿Sienten que es free response?
Yeah, me mandaron un email.
Sí, también a mí. And they chose to take it from the 11 to 22. They should have chosen later.
May 11th through 22.
No, they sent the actual one. It's on the 12.
Oh, really?
Yeah. Miss Analio sent it on mine.
Okay, vamos a ver. If we suppose that we have a free response, ¿les dijeron cómo iban a hacer esos problemas? ¿Cómo iban a hacer todo esto en el examen?
Most exams will have 1 or 2 free response questions, and each question will be timed separately. Students will need to write and submit their responses within the attached allotted time for each question.
¿Cómo lo van a submitir?
Students will be able to take exams on any device they have access to, computer, tablet, or smartphone. They'll be able to type and upload the response or write responses by hand and submit a photo via their cell phones. Entonces,
¿Mira foto?
haces el examen en papel y lo mandas.
Ok. Bueno. Entonces, vamos a tener ¿cuántas preguntas multiple choice? Digo, free response.
2.
¿Nada más?
That's what it said. I don't know.
1 o 2 free response questions.
Damn. Imagine not
No
knowing them.
multiple choice?
No, that's multiple choice.
Wow. Vaya pues.
Pero ¿cómo van a hacer
Eso
nomás
cambia un
dos?
poquito todo.
En 45 minutos.
Because they're long.
Yeah, but I mean, yeah, I guess.
But imagine you're like, almost skip this one, and then the next one's just like this hard.
Con
Can't
dos
skip
preguntas, ¿cómo vas a saber si if you get one right and one wrong? How are you gonna go if are you gonna get a 3? Like nobody's gonna get a 4. Like how do you get a 4?
Points.
I mean,
guessing.
they have like
Oh,
Yeah,
Oh,
like one question is gonna be like
this points.
A, B, C, D, E, F, G, you know?
mhm.
the whole alphabet into one.
Mhm.
That's
Ahora
what
déjenme ver, muchachos.
So they might do like in chemistry, like one question ask you about this, and then they're asking you limits, and then derivative of this, and then you know what I mean?
Mhm.
Like going
Yeah.
over every topic on one situation.
Ok, let me see. Vamos a ver. Ahora vamos a ver, por ejemplo, este problema. Let me just check. A ver, ¿lo alcanzan a ver? You see the problem?
No.
Oh. Ok, entonces déjenme cerrar esto. Ahora sí. This one. Ok, ¿ven ese problema? ¿Ya?
Sí.
Ok, déjenme verlo aquí. So, que no puedo verlo aquí. Vale. Ok, ese es el problema. That's it. Okay. For instance, this could be one of the problems in the AP test. 4 questions. You have 45 minutes for 2 problems. So significa que son like 20 minutes per problem. Now, you have, I don't know exactly how many points, but usually every one of these problems was 9 points. So the 9 points were distributed in 2s or 3s, depending on how difficult was every question, correct? So you were adding points depending on how well you were answered. If you don't answer this, you get no points. If you answer all 4, you get correctly, you get the 9 points, and so on. Nos vamos a poner, por ejemplo, this one. If an object moves along the x-axis with initial position at x equals 2, the velocity of the object at time t positive is given by bt sine pi over 3t. Okay? Let's do this. Let me just write this one. This is b of t equals sine pi over 3t, right?
But you just plug in T for 4, right?
Vamos a ver. Let me just go back to the screen. Stop. This is the velocity, yeah? Now, if you want the acceleration at t equals 4, right?
Acceleration.
Déjame ver otra vez. Sí, what is the acceleration at time lt equals 4?
Tienes que encontrar el derivative, right?
Yeah. So, you have to remember the definitions. Velocity is the derivative of the position respect the time, correct? X is a function of t, position, correct? If it's in the x-axis, xt is this value, correct? This is the x-axis. Xt is the particle is moving back and forth. What is the definition of the acceleration? Acceleration is derivative of the velocity respect the time.
Yeah.
Correct? Now, something important. If you want the position is the integral of the velocity respect the time, because you have to get the reverse. You
Yeah.
have to solve this equation. You integrate, you get this one, correct? Okay, so if we know that is basic, so acceleration is dv dt. So I have to take d of t of sine pi over 3t, right? And that is equals to what? A ver, Leo. Derivative
Cosine.
of the sine?
Cosine
Cosine.
Cosine pi over 2t or pi over 3t
times pi
times
over t times 1.
Correct. Pi over 3 times 1. Okay?
there you
Okay, here you can use the calculator because este problema, si no mal recuerdo, es calculator allowed. Yes, it's calculator allowed. Right? So the only you have this a at 4 is simply cosine of 4 pi over 3. And that is my answer. Now, ¿esto cuánto vale?
Pero times pi over
Times
3.
pi over 3, correct. Times pi over 3. Okay? So, si usamos, por cierto, le requerirían una calculadora. ¿No pidieron una calculadora ustedes? Never
Yo-
were over there in the
Sí.
Galina Park?
Yo ya tengo.
Okay.
Y también, Ramírez, vamos a poder usar el papel que usted nos dio de todos los properties. Sí,
Mhm.
Pues sí.
porque vamos a tener resources. Entonces podemos usar ese papel.
Ujú. Pues sí. Por eso les digo, no sé,
Oiga, Ramírez,
señor.
y ahí cuando hizo el derivative de lo que estaba adentro, ¿por qué no puso el 4 afuera también?
El 4 is the t. It's
Yeah.
not the derivative.
It's just pi over 3 outside.
Ajá, déjame ponerlo
Inside
otra
it.
vez.
And then he plugs in the 4 for the t.
Pi over 3 times t, correct? Entonces, derivative of the sine cosine, pi over 3t, times the derivative of this one, this is pi over 3 times 1.
Because
Then
the
this is
derivative
my
of t is
thing,
1.
evalúo en 4, I evaluate in 4, right? And then I get the answer. Well, whatever is the answer, vamos a poner aquí control, this is 1, okay. Pi divided by 3 times pi divided by 3, right? So we get this one, we get negative 52359. So it's negative 0.52. And then usually you have to get 3 or 4 decimals. This is good. Or you can round, you can put here 36. And then there are no units, creo. Let me see. No, there are no units. Simplemente, like in physics, we don't have to worry about the units. Okay? So this is my acceleration. Son unidades de distancia sobre tiempo square, correct? So, situation, you have to remember the definition of the acceleration as a derivative. You have to remember the derivative, the chain rule. Then you evaluate the function, and then you get your answer.
Entonces tienen physics en un calculus exam.
Physics concepts, really.
Yeah.
Basic physics concepts, correct?
Yeah.
So not a big deal. Yeah. Déjame borrar. B of t equals sine pi over 3t. Okay, so is x of, ¿cuál era la initial condition? X of 0 equals 2, okay. X of 0 equals 2. Okay, well, we have that. What is the next question? Let me see. Let me share screen. The next question is, consider the following two statements. Statement 1. For the interval 3, 4.5, the velocity of the object is decreasing. Statement 2. For the interval 3 to 4.5, the speed of the object is increasing. Okay. Now here. Velocity. Let me just go back to this one. Let me just put this one. You
It'd be
have
positive
two,
to negative.
velocity and speed. Are they the same or they are different?
They're different.
Why?
One's
Yeah, different.
velocity is displacement over time, and speed is distance over time.
Velocity has direction.
Mm. Okay. This is important. This has direction. Right? And this is magnitude, correct?
Uh-huh.
It's very important. Now, in your physics classes in college, what you're going to see is the velocity is a vector. Correcto? The
Yeah.
velocity is a vector. And the speed is the magnitude of the vector. Is the vector size. Correct?
Yeah.
So it's the size of the vector. Correcto? So they are different. This has no direction. It's just a scalar. Is what you're going to see in the college. Velocity is a vector. Acceleration is a vector. Position is a vector. So this is a different thing. Okay, well. So is the interval 3 less than t less or equal to 4.5. Okay, how can we know, yes, the velocity is increasing or decreasing? Dice
If
aquí,
it's negative,
velocity is decreasing, velocity is increasing. ¿Cómo lo puedo saber? How can I know that?
It gives you how the graph is gonna look like on the original question, doesn't it?
Decreasing.
if it's
How?
the acceleration.
Acceleration, that's correct. Yeah?
Oh, so it's a
Remember-
negative acceleration.
A ver, fíjense
Yeah,
bien.
it's positive or
Yeah.
negative.
Let me suppose I have this function, right? This is my function. Poner un poquito mejor. Like this, right? Suppose this is my function, right? So this is fx. Now my situation, and this is the point A, right? Now my question is it 0 and this is B. Well, vamos a ponerle C, A. Okay? Now, if I ask you on what interval this function is increasing, what interval is that?
From A to halfway to C.
You see, here is increasing, correct? And here is decrease, correct? Why?
Oh, is this a velocity over time graph, or what is it?
No, it's any graph is a function fx. It's a function fx, any function. So my idea is I have this function, there is a point C that is the top, and then from A through C is increasing or decreasing, from C to B is increasing, right? So here this is increasing and here is decreasing. That's correct, because the derivative is positive on AC, correct? And what happened in C and D and B? The derivative is negative.
Right.
So increasing or decreasing in calculus is related with the tangent, the derivative. If you have a positive tangent, the function is increasing. If you have a negative tangent, the function is decreasing. So this is the point. You are going to see if decreasing is with the acceleration, right?
Yeah.
How's the acceleration?
If it's positive, then it's increasing. If it's negative, then it's decreasing.
This is A positive, right? V increasing, right? Increasing. If A of t is negative, B is decreasing.
So it's decreasing?
If the acceleration is negative,
Didn't we already measure it though? At 4?
Well, I think it's
No.
just hypothetical.
It's on an interval. Here.
Yeah.
Aquí te dice, on the interval 4.5, the velocity of the object is decreasing or decreasing. Which one? So
we
you
take-
know that in 4
we
is
evaluate-
negative, correct? Yeah?
Mm-hmm.
Okay, but there is a situation. It's just a value, right? A ver,
Yeah.
aquí así, this is, okay, nosotros tenemos que A of 4 is negativo 0 point, I mean, right here, is negative 0.523, 524. Okay, I suppose that one, right? So it's negative, but this is just a value in 4, right? You don't know if the function, and this is 4, for example, this is 3, and this is 4.5. Possibly the function is doing this, correct?
We can't see.
We can, oh, like this one, right? So you don't know this one. A lo mejor this is the negative 4.5, but there is a 0. And before this point and 3 is positive. So you don't know. You must know a way to this one, to know this one. So it's okay. I know the derivative. Acceleration of the time is pi over 3 cosine of pi over 3t. Okay? Now, because this is a free response, correct? A free response, and you can use resources. Well, we only have to what? To plot this thing, correct? To plot this. So, okay, let me just go to the menu, insert a graph.
We already forgot how to do this, Ramiro. You don't let us use calculators.
These ones?
que se le olvidó cómo hacerlo.
Oh, I have calculators here. So, tú tienes una, ¿no, Brandon?
Sí.
Areli. David.
Sí.
On
Leo.
la computer.
No, pero ¿necesitas una calculadora? Que yo tengo
No,
aquí en
no,
la
no.
casa.
I'm just saying.
So, ya en la escuela no les van a dar que yo sepa. Pero si ven allá, ¿ven las calculadoras?
No.
Ahí.
Leo, it's better if you have a real calculator, dude.
Sí. Entonces, te puedo dar una nomás. Tú dices cuándo la recoges.
¿Y
¿Sí?
para cargarla?
Pues un cablecito nomás, USB.
Yeah, it's a USB mini.
Sí, no es problema. Es un USB y un cargador normal de corriente USB. ¿Correcto? So, entonces vemos esto. Vamos a poner aquí la función. Let's put the function is cosine. Vamos a poner aquí cosine. Oops, cosine. Parenthesis. We have to get this in radians. Pi over 3. Vamos a poner aquí pi divided by 3. And then the pen enter divided by 3. X. And then we press enter.
Puso el pi over 3 outside. Ramírez, puso el pi over 3 afuera.
No importa. El pi over 3 solamente la estira o la baja.
Oh,
right?
okay.
Eso no importaría mucho. Right? Entonces ahí tienen la función. Más o menos la ven. Right?
Yeah.
Medio borrosa, pero bueno. Okay. So, let me see. It's between 3. Let me just put, here is the 3. The 3 is like right here. Bueno. Déjame hacer algo mejor. No, cancel. Escape. Let me just put this one on the board. Oh, escape. Déjame poner la calculadora que tengo aquí en el...
En la computadora.
Sí, debo tener una.
Ya, mejor. ¿Sabe que Texas Instruments está dando calculadoras en la computadora gratis?
Sí.
What? Really?
Digamos el emulador. El emulator.
Yeah.
¿Sí? Pero ahí tú sabrás si quieres usar la calculadora en la mano o quieres usar la computadora.
Es mejor en la mano.
Yo diría.
Yeah.
Déjenme prender esta cosa.
Amazon Basics.
Entonces, graph. Vamos a poner aquí. Pi. No. Pi. pi x. Okay. Okay, let me just ahora compartir pantalla con ustedes. This one. Now you see the calculator?
Yeah.
Okay. So the question is between 3, okay, 1, 2, 3, and negative 4.5, like right here, you see? This is 3, this is 4, 4.5 is like right here. So how's the acceleration between 3 and 4.5? Is this the function? Yeah. Is negative, is below the axis, correct? So if you see this one, right? Yeah. This is 1, 2, 3. Here is the 3 right here. Here is the 3. Here is the 4. And the 4.5 is like right there, right? So between 3 and 4.5, the acceleration is negative. So, well, this key, we put it here. Negative. This is on 3 less or equal than x, and t less or equal than 4.5. So what is the conclusion? B of t is decreasing.
Pero en 4.5 es 0, ¿no?
Ya. Pero creo que aquí el intervalo. Let me see the interval. No, I put the equals. It really should be without this one, right? With like that. Sin los less or equal. This is just the less and less. Correct? So B of t is decreasing. Okay? Now, vayan calculando su tiempo de hacer esto, because we have to write, we have to justify, we have to check, right? You have to write clearly, you have to take the picture, you have to submit. Okay?
We have a 5-minute period for submitting at the end.
Okay, that's good.
Ya nos dan 5 minutos.
Okay, let's go now again to the problem right here. Z. What is the total distance traveled by the object over the time interval? 0, 4. Okay. And this is the important part. Yeah. The total distance, correct? So you know that the x of 0 is 2, correct? This is the initial position. Is what I see here. Yeah, initial position is that one, right? And this is, well, this is total distance. Remember this. The particle could move to the right and then go back to the left. And then the displacement is just the net distance from the initial point. But the total distance is all the way back and forth, correct? Yes, because when the velocity is negative, for instance, in this case, well, this is the 0 and this is the x, right? So this is the x here. Then is the total distance. So if you get a negative, you subtract the distance you run, and then you can get, if you are in the same position, your displacement is 0, but the total distance is not, is twice this interval, correct? So in this case, what you have to do is, well, the distance, the net distance, the net displacement, if we can use d, is going to be the integral from 0 to 4 of the absolute value of vt dt. Why the absolute value? Because when the velocity is negative, goes to that direction and subtract the distance. When it's positive, increase the distance. When it's negative, decrease the distance, correct? So that's why I put the absolute value. Is really counting positive this and positive this, so you add everything, correct? Bueno, ¿qué tendríamos que hacer? This is, well, this is the integral from 0 to 4, absolute value of sine of pi over 3 of t dt. Correct? Okay, now, is a problem here? Well, let me see. Let me see, go to the calculator. Let me just share with you the screen. Right again, calculator. So this is the acceleration, correct? Let me just put another graph and do the velocity.
Yeah.
Sine is pi
Over 3 times t.
pi over 3 tx, right there.
Yeah.
And then I see this one. I see this one. So it's from 0, 1, 2, 3, 4, okay? So if we take the displacement, just the integral, let me just move this down. Remember that the area here is positive, so this displacement is to the right. And here, this is negative, so the displacement is to the left. So you're going to do something like this, correct? So
At
you
x
go
equals 6.
forward and this one. Now, what you have to do is add this area and also add this area. You need a total area to get
Oh.
the back and forth, correct? The forward and back, correct? So that's why I'm using the absolute value, because I'm flipping this. I'm switching, I'm just making this negative positive.
Ramirez, you can just do it on the actual calculator, right? You can just take the put absolute
Mhm.
value on sine.
Yeah, claro. So if we do that, let me just go to the screen. Then I put here a calculator page. And then I can put here menu, calculus, integral. And then you put here 0 through 4, correct? Yeah. And there is something important here that I have to do, right? So this is the absolute value. Let me just put here the absolute value right here. And then go pongo aquí sine, parenthesis, pi over 3. Pi over 3. Pi over 3 x, and here the dx, correct? So you press enter and you get a number, correct?
A la madre. Este
So,
nomás es con el cash, ¿verdad?
28387. Sí, por eso les digo que pueden recoger una calculadora conmigo.
Ramirez,
Yeah.
voy a agarrar una.
Ok, bueno, ahora viene este problema, right? ¿Sí? The
Ah,
initial
la madre.
condition. Let me just, okay, everybody understood this one?
Sí.
Ok, bueno. Voy a,
Entonces, ese número es el displacement, ¿verdad?
bueno, básicamente, pero
Yeah.
vamos a ver, ahí hay algo importante. The integral is this one, but really this is what happens, okay? Let me just take this one, really. This is dx equals absolute value of t dt. When I take the integration, both sides, correct? This has to be from 0 to a final distance, correct? From 0 to a final distance. And this is from 0 to, ¿qué sería? A final time of 4, correct? So this is d in 4, and this is really d in 0, or x in 0. X in 0 and x in 4. So this is the position in 0 at time 0. This is the position in 4. So this is really x at 4 minus x in 0. Now, what is x in 0? It's a 2. You see here, that's a 2.
Yeah.
So this is position in 4 minus 2 equals 2.387. What you have to do with this 2?
You just add it.
So it's 4.387. This is the net distance.
Ya te entiendo. Because you have to do the plus t.
So, but I have to do this integration in both sides. We're going to practice these problems more, okay? So, no problem. Ok, bueno, vamos a terminar el problema para hacer, para cerrar hoy. Right? The next one, let me just share the screen with you. Right here, right here. This one. Again. So what is the position of the object at time equals 4?
Okay.
What is the position of the object at time equals 4? Okay. Vamos al screen. Okay. This is the net displacement. So, fíjense bien. This was with the absolute value, right?
Oh, yeah, that's
so you have to get the net the distance, the displacement is without the absolute value.
Right.
Correct? So we have to do exactly the same, but without the absolute value. Correct? So we have to do exactly the same, but without the absolute value. So we go to the calculator. Let me just go here. See this one. And then you just repeat the integral. So we have menu, calculus integral. So from 0 to 4, no 7, 4. And then I put here sine pi, right, over 3
And
x
that's
dx. And remember that I add a 2 plus, correcto?
mhm.
2 plus, and then we press enter and control enter. En todo caso que no me dé esto, es control enter. And I see that this 4, 4, 3, 2, 4, 3, 4, 3, 2, 3. This is less than the 4 we got before. ¿Se acuerdan? Right?
Because you're subtracting.
Because you are subtracting the area that is below the axis. So
Yeah.
this is the net displacement from the origin. So it's 3.5 units more or less at the right of the origin, right? The total distance it recorded was 4.38. So back and forth, remember? So this is the way we solve these problems. Now, make your numbers about how long it's going to take us. Ahora, no sé qué problemas vayan a poner. Easy, fácil, difícil, difficult, I don't know.
Hey, Ramirez,
Yep.
should we be watching on YouTube the AP Calculus classes since they're like specifically for from College Board? You think it'll help us out on the test?
Ok. Sí, hay AP clases en YouTube. Pueden ir al canal del College Board y vean cómo trabajan ellos también. So, yo resuelvo los problemas que tengo release, ¿correcto? También está ¿cómo se llama? El sitio de AP que estuvimos usando una vez. ¿Sí? Ya saben cuál. ¿Sí?
¿Cuál?
Uno que hicimos una vez unos trabajos ahí, ¿cómo se llama? Como no me gusta a mí en especial porque es muy difícil localizar algo que me interese. Bueno, todo está interesante, pero todo está por las definiciones que ellos usan.
Ah, okay. Yeah.
¿Sí?
Sí.
Entonces, está ese y está el canal. Digo, pueden usarlo. Ahorita no grabé esto, ¿sí? Pero
Sí.
creo que se les quedó más o menos. Si
¿Sí lo
quieren...
grabó?
No, no lo grabé.
Porque dice recording.
¿Es recording?
Sí.
A ver, déjame ver. Ah, pues sí. Sí, entonces sí se grabó.
Sí.
Ok, bueno.